Hi class, for this video we're going to work on problem 16. So we're going to be plugging in coordinate points, and just for this one I'm going to use a total of 3 coordinate points. So let's actually start with, I'll just say use the equation of x plus y is equal to -2. And in the first step that I'm going to do, I'm going to subtract the actual x's. So give me just a second. Okay, so this is just so that it's easier for us to evaluate. So what I'm going to do is I'm going to subtract the x's from both sides of the equation. And then we're looking at a y is equal to -x minus 2. So this is the equation that we're going to use to plug in the x values. And what I'm going to do is I'm going to start with a negative value. In this case, let's actually start with let x is equal to -1. And as you plug this value in, you're going to get -1 minus 2. So y is equal to 1 minus 2, or y is equal to -1. The coordinate point, it's actually going to be, in this case, as an x and a y, we're looking at -1, comma, -1. And let me plot this one on the actual Cartesian plane. So -1, -1, it's going to be here. Next coordinate point, let me pick 0 since it'll be easy to evaluate. So x is equal to 0. So our y value is -0 minus 2. So y is equal to -2 as an x and a y. This is equal to 0, comma, -2. So we're going to go to this point here. Okay, so next value, we're going to use x is equal to 1. I'm trying to pick technically 0, something on the negative, something on the positives. So on the value of 1, our y is equal to -1 minus 2. So y is equal to -3. So our coordinate point, it's going to be 1, comma, -3. So 1, 1, 2, and 3 happens to be here. Let me just make those dots a little bit thicker. And then the last portion of it, it's going to be to draw the line. Notice that, well, all of our coordinate points, and let me just box this one in, are aligning in a pattern because, well, your equation happens to be linear. There's no exponents. So the last step to complete the sketch of the equation, it's going to be to try to connect those 3 dots. So in this case, we're going to be drawing a line that goes through those points. Oh, it actually does a curve. So give me just a second. Okay, so that's pretty much it. That's the closest I could get to a straight line using this software. In any case, we're putting the coordinate points, drawing a straight line as accurate as we can. Don't forget the arrows, since technically we're only looking at a couple of coordinate points. But your line has technically an infinite amount of coordinate points. Let me show you what this one looks like with technology. And in this case, you'll be able to see, well, that our line actually continues indefinitely. Let me also put in the arrows on the axis. But this is what the line looks like using technology. Notice that, well, I label all the coordinate points that I'm using. For your sketches, if you're using coordinate points, I want to see, well, technically the work that leads you to them. And once again, because this equation happens to be linear, you're looking at a straight line. Let's actually move on to another problem. And on another problem, I'm going to use a shortcut. So let's actually do problem 17. And on problem 17, I'm going to do the same approach as before. So what I'm going to do first is use the original equation. So use, in this case, x minus y is equal to 6. And then let me solve for the actual y values. So get rid of the x's, and we end up with negative y, it's equal to negative x plus 6. And then I'm going to be dividing by negative 1 each of the actual terms. So we're looking at y is equal to x minus 6. This is our main equation. And then from here, I'm going to be retrieving, and I'm going to do this one with the shortcut. Your y-intercept, it's technically 0, negative 6. That happens to be the constant. So as a point, we're going to be looking at coordinate point 0 and negative 6. So 1, 2, 3, 4, 5, 6. That's going to be here. Let me count them again. That happens to be there. Let me make it a little bit thicker. And then from here, we're going to basically use the value of the slope. So the value of m happens to represent the value that multiplies the x's, because technically you're not writing a number there that represents 1. So that's going to be 1 over 1. So from the actual y-intercept, I'm going to go 1 unit up and then 1 unit to the right. So I'm just following the value of the slope. That's going to give us the second coordinate point. And then in the last step, we're just going to connect those two. That would be our line. Don't forget the arrows. And let me show you what this one looks like with technology. Here you see the 2 coordinate points. I use technology to actually graph it. Let me put the arrows on the actual line. Let me also put the arrows on the axis. But that's actually it for this one. Here, using technology, you can see the y-intercept 0, negative 6, and technically there is your 1, 1, which the software gives me 1, negative 5. As you're using the value of the slope, I'm just basically going 1 unit up and 1 to the right, or I'm using the actual coefficient of the x's. That's actually it for these 2 problems. I'll put the other ones in a separate video.